converting into the integral form, it's, let's say, 1 to infinity x ln of x to the power of p. The obvious substitution, hopefully it's obvious, is this. So du is equal to 1 over x dx. Okay, so we have that right there. So that can be replaced with du ln of actually, you know what, we should change this to 2. The reason why they started from 2 here, right, because if it was ln of 1, it would be 0 at the bottom, which would become undefined. So we should also start the integral from 2. It's very subtle, but it doesn't matter that it starts from 2 rather than 1. So this is ln of 2 to infinity, and we get x to the power of u to the power of p. Okay, so ln of 2 infinity u to the power minus p du. So 1 over minus p plus 1, u to the power minus p plus 1. This is improper integral, so you actually have to do this. Limit t approaches to infinity. I'm going to write as 1 minus p. 1 minus p. Okay, so we have 1 minus p, t to the power 1 minus p, minus ln of 2, 1 minus p. Okay, t is approaching infinity, right? So what is it, how do you know this is going to converge? What does it depend on? These are constants, right? So p is going to be like 1, 2, it's going to be some constant. This is constant, ln of 2. So only it depends on this. In the current form, it looks like it's going to go to infinity, which is not what we want. We want this to be so that it goes under, so it's like a constant over infinity, so it converges. So to ensure that, this needs to be negative, 1 minus p. Okay. In fact, it can actually be 0 too. Okay. So that means p has to be greater than or equal to 1. Greater than or equal to 1. Then it's converging. So in this original question here, p needs to be greater than or equal to 1. Make sense?